Hola humans, today we are going to go over the quotient property. So I'm going to follow the following 3 steps for all of these questions. We're going to look for our invisible ones. Then we're going to divide our coefficients, and we want to think about those coefficients as being our big numbers. And then for step 3, we're going to subtract our exponents. So we're going to subtract those little numbers that are next to our bases. So looking at example 1, my exponents are 9 and 6 because those are the small numbers. My base would be the x because that's the thing in front of our exponent. And I don't have any coefficients here. Those would be big numbers in front of the variable, so I don't have them. Okay, also looking at this problem, I don't have any invisible ones because both of my exponents are present. So in this case, I'm going to jump straight to step 3, and that is to subtract our exponents. So again, our base was x, our exponents are 9 and 6, so 9 minus 6 would be 3. So my final answer here would be x to the power of 3, and we're done. All right, looking at example 2, we have more going on here. Now I do see that we have coefficients, and then looking across, I'm hunting for those invisible ones. The top 2 have exponents, so those are great, but I can see at the bottom that x was missing an exponent, so I'm going to put that invisible 1 here. Going back to those coefficients, we have 10 divided by 2, which is 5. So I can think about reducing that fraction. It just reduces to 5. Then I want to look at my bases. We have x's and we have y's. So looking at my x's, I see that I have 8 on top, 1 at the bottom, so I'm going to do 8 minus 1. Looking at my y's, I see that we have 6 on top, 5 on the bottom, so I'm going to do 6 minus 5. So cleaning all of this up, we're going to have 5x to the power of 7 and y to the power of 1. But remember, anytime we have an exponent of 1, we don't need to include that in our final answer. So what I've boxed here is math pretty. All right, looking at example 3, we're going to first start by finding all of those invisible ones. Looking at this, I can see my top h is missing an exponent, so I'm going to put that invisible 1 right next to that h. And now I'm going to look at my coefficients. So when I look at these, I see that my coefficients are 2 and 8, and I want to divide those. So if I'm thinking about 2 divided by 8, we are going to get a decimal. Just wanting to reduce that fraction. 2 divided by 8 reduces to 1 over 4. You can also think about it as 8 divided by 2 is 4. The first number you say in your brain is where your answer goes. So if I said 8 divided by 4, 8 is at the bottom, so 4 should be at the bottom. Now we're going to look at our variables. We have 2, we have g, and we have h, so those are our 2 bases. And now we're going to look at subtracting those exponents. Here we have 3 on top and 2 at the bottom, so I'm going to do 3 minus 2. For my h's, we have 1 on top and 5 in the denominator, so I'm doing 1 minus 5. So cleaning all of this up, we are going to have 1 over 4 times g to the power of 3 minus 2, which is 1. And then we're going to have h to the power of 1 minus 5. 1 minus 5 is negative 4. And then I'm going to go back and I'm going to erase that exponent of 1 because remember, in our final answer, we do not need that. And that would be it for this video. In another video, I'll show you how to work with negative exponents. All right, looking at example 4, same thing. We're going to start by looking for invisible ones. It looks like the c is the only one missing an exponent. And now looking at those coefficients, we have 3 here. I don't see anything at the bottom. You can remember that as 1. So 3 divided by 1 is still 3. And now writing my bases, we have 3 of them this time. We have A, B, and C. And again, we're going to follow the same thing with subtracting our exponents. We always subtract top minus bottom. So here we have negative 4 and negative 6. So I'm going to have negative 4 minus negative 6. So yes, I'm going to have 2 negatives in between the 4 and 6 because I have negatives from the exponents and my process is to subtract. Looking at our b's, we have 2 on the top, 3 in the denominator, so I'm going to do 2 minus 3. And then my last one over here, we have 1 in the numerator, negative 4 in my denominator, so I'm doing 1 minus negative 4. Again, I have 2 negatives in the middle because it's top minus the bottom number, even if that bottom number is negative. Cleaning all of this up, we're going to have 3. A, negative 4 minus negative 6 is the same as me doing negative 4 plus 6, which would give me a positive 2. Then we have b to the power of 2 minus 3, which is negative 1, and c to the power of 1 plus 4, which is 5. Now, if you are someone that's looking at this and you're like, oh my gosh, I kind of understood the subtraction, I don't get how you got the final answer with the exponents, keep in mind that you usually have access to a calculator. So if I were to type all of this in, just make sure you're including all of those negative signs. So I'm going to put the green one for my a's in. So we have 4, which is negative, minus my 6, which was negative, and I get 2. So that matches my base of A. For base B, 2 minus 3, I get negative 1, so I write it. For my C's, we did 1 minus my 4, which was negative, and I get 5. Okay, so if you are stuck on these, and you're working open-ended questions on your test, show that you're subtracting top minus bottom like we did here in this step, and then use your calculator to get those final values for your exponents. All right, looking at example 5, this is our last one for today. I'm looking for those invisible ones. Here, I do not have any exponent that is missing from a base, so I have 0 invisible ones here. So I'm going to look directly for those coefficients. So when I look at them, I don't have anything in the top. So again, I could think of that as the number 1, and I do have 4 in the denominator. So I'm thinking about the fraction 1 over 4. That fraction does not reduce. So when I divide 1 over 4, it's going to stay as 1 over 4. Then looking at my two bases, I have A and I have B. So I'm going to follow that process of subtracting top minus bottom number. So I'm going to do 3 over 2 minus 1 over 2. Again, even if you don't feel confident with fractions, just write it top minus bottom number. And then same thing for our b's. So we have 5 over 3 minus 2 over 3. All right, simplifying all of this, that 1 over 4 is going to stay. Then I'm going to look at my a's. 3 over 2 minus 1 over 2 would give me 2 over 2, which is just 1. B is 5 over 3 minus 2 over 3, which becomes 3 over 3, which is also 1. Again, if you were to check that calculator, go in order of what you have. So for that green one, I have 3 divided by 2 minus 1 divided by 2. And I get 1. Looking at my b's, we had 5 divided by 3 for that first fraction, minus 2 divided by 3 for that second fraction, and I also get 1. So looking at my final answer, we have 1/4 a to the power of 1, b to the power of 1, but again, we don't have to include those ones as our final exponent. We can leave it just like this.